Hey guys, welcome back to General Chemistry. Today we're going to start the chapter about gases. For those of you taking my course, here's kind of the plan of attack for this chapter. I do move the kinetic molecular theory up a little bit, so your textbook has it at the very end of the chapter. I like to sneak it in to the beginning, so I'd like to refer back to it as we're getting through each of the individual gas laws. Today's lecture is just going to be an introduction to gas. So when we think about gas, one of the first things that comes to mind is talking about pressure, right? So when we study gas, we're going to study one of the properties of it, which is pressure. So pressure is defined as the result of collisions between gas molecules or gas atoms and their surfaces around them. So something that has a high pressure would have lots of collisions. Something that has a low pressure would have just a few collisions. Here is the mathematical definition of pressure. So the force exerted per unit area by gas molecules as they bounce against the surface. So that was words, and then we see the formula here, pressure equals force over area. Not a formula that we're going to use specifically this chapter, but certainly can help us understand the concept of what pressure is. So here we've got two containers, and both of these containers, we'll say that they're the same size, right? So the area that the gases are acting on is the same. So the bottom of that equation is the same. For the jar that has a lower pressure, we're going to see less particles there. Less particles means less collisions with the side of that container, which means a lower force is going to be registered. So that would mean a low pressure. And the other container, if it's the same area, it's definitely got more particles in it. So more particles would mean more collisions with the side of that container, and a higher force would be registered. So we would say that one has a higher pressure. So when we think about the pressure as it relates to gas molecules or gas atoms, we're really talking about the number of collisions with the container. Units for pressure. So the unit that we're going to use the most this chapter is something called ATM, so atmospheres of pressure. So this is going to be your average pressure at sea level. So here in Wilmington, we are essentially at sea level, right? So our pressure would be relatively 1 ATM. The SI unit for pressure is the Pascal. So if you were to take like a physics course or a physical science class, Pascal would likely be the unit that you would use for that class. Not something that we use often in chemistry, but I just wanted to let you know Pascal is the official SI unit. And then lastly, we've got millimeters of mercury. So if you've heard of something called barometric pressure, barometric pressure is often given in millimeters of mercury. So how in the world did we go from a length measurement, millimeters, to a pressure measurement, right? So here we've got a very basic kind of barometer. In our barometer, we've got a reservoir of mercury. And then in that reservoir is going to be some sort of glass tube attached. And inside here is a vacuum where it's evacuated. So the way that we measure pressure here is as the atmospheric pressure goes up, it's going to push down or create some sort of drag on this mercury. So we push down on the mercury, and that weight is going to cause the mercury to push down into the reservoir and up into the tube. So let's say our mercury is here at 760 millimeters, so we'd measure that from top to bottom. As the pressure rises, we'd have more weight on this reservoir. This line may go up to the top, so then maybe it's 770 millimeters high. And as the atmospheric pressure goes down, it wouldn't feel such a weight here. So the mercury in the reservoir would be allowed to lift up, which would cause the mercury in the tube to go down. So instead of being at 760 millimeters, as the pressure drops, this would go down. So maybe it's 750 millimeters high. So that's how we use a barometer to measure barometric pressure. As I said, ATM is going to be the unit of choice for this chapter. But in practice problems and whatnot, you may see millimeters of mercury, you may see pascals, and you would just have to convert to ATMs. So that's your introduction to pressure. I hope you guys found that helpful.